Anyways, now this is our first example under Dedekind. So the question gives us A is equal to x belongs to the set of real numbers such that x is less than or equal to 2, and B is equal to x also belongs to the set of real numbers such that x is greater than or equal to 0. Now we are going to show whether the ordered pair A, B is a Dedekind. We are going to show whether this one is or is not a Dedekind. Now we are going to show whether the ordered pair A, B is or is not a Dedekind. How are you going to show this one? Now let's see how we are going to solve this one. We are saying that set A is equal to the set of real numbers which is less or equal to 2. So here the set will start from negative infinity up to 2. So it will be, let me use integers for instance, it will be, let's say negative 1, 0, 1, up to 2. And set B, which is equal to the set x belongs to real numbers. So we start from positive 2 up to positive infinity. So let me use 2. Let me set integers 3, 4, 5 up to positive infinity. Now this is what we are going to do. We are going to use this set to follow the conditions for Dedekind card. The first condition is saying that the union between A and B must belong to real numbers. So let's see, when you find the union between A and B, you see the numbers here, we are going to get real numbers. So that means that this condition is satisfied. Now let's move on to the next condition. Condition 2. We are saying that set A shouldn't be an empty set. And it's true, looking at this set, we can see that set A is not an empty set. And also set B shouldn't be an empty set. When you look at set B, that one too is not an empty set. It means that condition 2 has also satisfied. Now let's look at the condition 3. We are saying that E should always be less than, let me use F, whenever E is a member of the first set, that's the A, and F is a member of the second set, that's the B. So let's check. This is the first set, A. We can see that we have 2 here, and also we have 2 here. We are saying that this condition also implies that the intersection between A and B must give you an empty set. So before we go to even the E less than F, we can also look at the intersection between A and B, whether we are going to get empty before we check this one. So condition 3 is 2 in one condition. Let's see, let's try to find the intersection. You can see we have 2 here, we have 2 here. And since the intersection between A and B is equal to the set of 2, then it implies that since this condition has failed, it's not equal to an empty set. So we can say that A per B is not a Dedekind cut. So the condition that fails it is that A intersection B is supposed to give us an empty set. But looking at this one, we are having A intersection B, which is equal to what? 2. So it implies that since it has failed the third condition, this A per B is not considered as what? A Dedekind cut. In our next video, we shall also solve one example under Dedekind cut. See you next time.